Number 16, find the limit as x approaches 2 of 3x squared minus x minus 10 all over x squared minus 4. Well, when we're trying to find a limit and we're doing it algebraically without a calculator, our first thing is just to try to plug in 2. So that's what I'm going to do first. Okay, so when I do that, I'll get 412 minus 2 is 10 minus 10 is, I get 0. And then 2 squared is 4 minus 4 is 0. So I get 0 over 0. Doesn't mean I can't find the limit, I just can't find it that way. So what we're going to do instead is try to factor. So I'm going to have 3x divided by 3. Take 3 times negative 10 will be negative 30. And then think what times what would give me negative 30 but add up to give me negative 1. That would be a negative 6 and a positive 5. I'm going to divide the 3 out of the first set of the parentheses. So I'm going to have x minus 2 times 3x plus 5, so that's the numerator factored, and then the denominator factored is a difference of squares, so it will be x plus 2 times x minus 2. So the x minus 2's will cancel, so I'm left with 3x plus 5 over x plus 2. The goal of me doing that was to be able to now plug in 2 to find the limit as x approaches 2. So if I plug in 2 for my x now, I will get 11 over 4, and that will be my limit. Okay, problem 7. If f of x equals, 17, excuse me, if f of x equals e to the x, g of x equals x squared plus 1, and h of x equals f of g of x, then h prime of 3 equals what? So they're asking me to find a derivative of h. We know that h is equal to f of g of x. There's a couple different ways. We could use the chain rule on this one, but I think I'm just going to kind of plug in things and do it that way. What this means to do is to take g of x and to put it into f of x. So we're going to take g, this x squared plus 1, wherever c and x, I'm going to put it in the f of x function. So f of g of x will equal e to the x squared plus 1. Okay, then it's asking me to take the derivative of that. So then this is equal to h right now. So h prime will equal, this would be like e to the u, and my u will be x squared plus 1. My du would be 2x, and so h prime is equal to e to the u du, and so h prime will equal e to the x squared plus 1 times 2x, and it asked me to find it at h prime of 3, so now I'm going to plug in 3, so I'll get e equals 3 squared plus 1 times 2 times 3. That will give me 6e to the 10, and that would be my answer. Okay, number 18, if y equals cosine 3x plus e to the 3x, then y plus y double prime will equal. So we're actually going to add y to y double prime. Well, we know y, but we do not know y double prime, so we need to find that. So I'm going to start out by finding y prime. One thing on both of these, we can let our u be 3x, so u will equal 3x, and then du for each of them will be 3. So I'm just going to rewrite. Before I find the derivative, I'm just going to rewrite y as y equals cosine u plus e to the u. So y prime will equal, the derivative of cosine is negative sine u times du, which is 3, plus e to the u is just e to the u times 3 once again. Okay, and now we want to find y double prime. So I'm going to do y double prime equals, and I'm going to bump those. I'm going to rewrite this negative 3 sine u plus 3 e to the u. We're going to do the same thing again. So to take the second derivative, the derivative of sine is cosine, so it'll be negative 3 cosine u times the du again, and then plus the derivative of e to the u is just e to the u, or 3e to the u, excuse me, times du, which again is 3. So y double prime will equal negative 9 cosine u plus 9 e to the u, which will equal negative 9 cosine of 3x plus 9 e to the 3x. All right, but that wasn't what they were asking me to do. They said to find y plus y double prime. So now I'm going to add y, which was cosine 3x plus e to the 3x, and add it to y double prime. So negative 9 cosine 3x plus 9 e to the 3x. And so if I add those two together, I will get negative 8 cosine 3x plus 10 e to the 3x. Okay, number 19, find the integral from 0 to pi over 4 of secant squared x dx. If you know your rules, you know that the integral of secant squared is simply tangent, and then we're just going to evaluate it at pi over 4 and 0. So I'm going to have the tangent of pi over 4 minus the tangent of 0. And I know tangent is sine divided by the cosine. So this will be sine of pi over 4 divided by the cosine of pi over 4 minus sine of 0 over cosine 0. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2, so that will reduce to 1. And then on this one, sine of 0 is 0. Cosine of 0 is 1. 0 divided by 1 is 1. So 1 minus 0 is 1. Number 20. On the interval 2 to 5, the curve y equals x cubed minus 3x squared plus 5 is first of all increasing or decreasing, and then concave up or down. Okay, for A, to get increasing or decreasing, we do want to do the first derivative. So that will be 3x squared minus 6x. We want to set that equal to 0. So 3x squared minus 6x equals 0. I'm going to factor out a 3x. And then my zeros will be x equals 0 and x equals 2. So if I make a y prime chart, put 0 and 2 on it. Before 0, my derivative will be positive. Between 1 and 2, my derivative will be negative. Between or after 2, my derivative will be positive. So on this one, it says between 2 and 5, which would be this portion right here. My answer would be increasing, and it says justify. It would be because y prime is positive. Okay, on this one, is it concave up or down on that interval? Well, we need to get the second derivative. It will be 6x minus 6. If I set that equal to 0, x will equal 1. So if I make my y double prime chart, put 1 on it, I'm going to plug things into the second derivative. So if I plug 0 in, I will get a negative answer. If I plug 1 in, I'll get a positive answer. And it just said between 2 and 5. Well, 2 and 5 would be in this section right here. So I know since my second derivative is positive, I will be concave up. So it's concave up, and y double prime is positive. And there we go.